To lecture 2 of KV4000 programming, and today we'll be continuing the theme of computational thinking. So as before, here's a roadmap of the lecture, and you can see that there are slightly fewer blocks than before, and that's okay because this lecture is a bit more interactive and I'll be asking you to do a few more things. And as you can see at the end, there's an extra challenge or an extra depth movie that you can watch. Again, when you see the pause button, that's your cue to pause the movie and do something, whether that's just having a think about a problem or sketching something out. And for this lecture, I've included in the material a couple of blank worksheets, and you might find it useful to have these printed out. Also, you might find a pencil and an eraser may come in useful. So just to recap, the important thing about computational thinking is that it places the emphasis on the algorithm rather than simply on the code. Remember, programming isn't just about coding, it's about the development of algorithms. So you'll remember that an algorithm is just a series of steps that we need to implement in order to achieve a desired result. So last time, for example, we looked at an algorithm for calculating someone's pay based on their hours worked and their hourly rate. And in the advanced topic material, we looked at getting 5 millilitres of water using 2 beakers. Now in each case, there was a set of operations that we could perform, and we basically put these together into a sequence in order to get the result we wanted. So the algorithm is general in the sense that it's not tied to any one particular programming language or implementation platform. The program is the implementation of the algorithm, and that's the key thing to get across. It's just as important to make sure that we have our algorithm right before we even start coding, because no matter how good your code is, if your algorithm is wrong, then your results will be wrong. Now, of course, we don't expect everyone to always be able to write algorithms from scratch, certainly not at the beginning of a programming unit. That would be incredibly inefficient to be expecting people to write stuff from scratch all of the time, and it would ignore the fact that lots of clever people have spent an awful lot of time on coming up with efficient algorithms to solve many different problems. So the beauty of proper software engineering, where everything is made nice and modular and self-contained, is that we can take implementations of different algorithms off the shelf, available in what we call libraries, and use them in our own implementations. So one of the tricks of being a good computer scientist or a good developer is knowing which algorithms to use in which situation, rather than necessarily developing brand new complex algorithms ourselves. It's rather like being a trained mechanic, where you know precisely which tool to use to tackle a specific problem. If you don't know which tools are available to you and how to use them, you just end up bashing everything with a hammer, and you probably wouldn't last long as a mechanic. So it's important to understand not only what's available, but also a little bit about how pre-existing algorithms work. In this way, we gain an understanding of what's going on under the bonnet of working code.